Today we're doing problems together. One kid is explaining it to the other kid. They're sitting side by side. And on the first one, we're doing these contingency tables. We got 75 out of 600. Number two, we just had them complete that one. Who can explain that one for me? Yes, Lizzie.
Well, it's the seniors who eat their vegetables.
Seniors who eat their vegetables, is that the given part?
Yeah, that's the given.
And therefore?
So your answer is going to be out of 200.
Seniors who eat all their vegetables. I got to find eat all their vegetables. Is that this, or this? Which one is it?
It's love math, so it's 100 out of 200.
It's out of 200 because those are the ones that are possible. And then which of these that are possible do we want again? The loves math one. So we want these. So it's 100 out of the 200. You are right. Raise your hand if your person explained it correctly. All right, good. If they didn't, it's okay as long as you understand it now. All right, moving on to number 3. What is the probability that a randomly chosen senior who loves math has never seen a vegetable? All right, so figure out your given. Everybody do this one on your own. No teacher in the group, just do it on your own. Okay, give them some time to answer. Probability of random chosen senior who loves math. Ooh, that sounds to me like they're giving me the fact that the person loves math. So therefore, I got to find the loves math. That would mean these are all the things that are possible. This row right here. So it's out of 125. You agree? Okay, good. And then has never seen a vegetable. So of those, I got to look for has never seen a vegetable. Oh, in case you couldn't see it. Sorry about that. The never seen a vegetable with these guys. So it would be 5 out of 125. Raise your hand if you agree with me. Okay, good. All right. Next type of problem. And just for those at home, if you want to pause on this screen, that's the list of the types of problems that we need to know for this final. We'd already talked about Venns yesterday, so we kind of skipped over that today. The next type of problem I want to talk about here is pizza problems. I looked up last night all the types of Domino's pizza, all the toppings that they have. This will be kind of fun for next time too, because I didn't know that you could order extra large pepperoni. Did you know that? As in like the pepperoni circles are, instead of like being normal size, they're like really big. So extra large pepperoni is an option. Okay. At Domino's, they have a total of 25 toppings listed. This is an exact copy of them. I did highlight them to make the difference. What can you tell is common about those yellow ones? That's the meats. And the 16 other ones are not meat. I just didn't want to like try to segment it into sauces and all that other stuff. So it's either meat and things that are not meat. Another thing to call your attention to is the white sauce. Had it the other night. It's really good. It ends up making the pizza kind of like a giant piece of what do you call that bread that they bake with the cheese on top of it? Like garlic bread, like garlic cheesy bread. It's kind of like that sauce instead of the pizza sauce. So then your pizza ends up tasting like, oh, this is a Domino's commercial for pizza eggs. Okay, let's move on. If I'm going to have 2 toppings out of the 25 total toppings, what's the total number of pizzas that I could order? Well, is it a C or a P? It's a C. All right, person on the right in the groups here, you're going to explain how to do this to the person on the left. I'm sensing that you guys are pretty much done. Did you have 25 choices and you're going to choose 2? Did you actually calculate that, somebody? What'd you get? 300 is correct. So this is real world. This is right off their website. So that means there's 300 different kinds of 2-topping pizzas you could order. Now I want you to just think with me for a second. If we made that 3-topping pizzas, would you expect 25C3 to be a bigger number? Yes, it is. It gets bigger and bigger and bigger and bigger until it gets to about the middle of the list, and then it goes smaller and smaller until you get to 25, choose 25, which would mean you have said, truly, I want everything on it. I don't know if anybody's ever done that. Probably be really expensive because it's like $1 per topping, right? Anyway, if you truly asked for everything on it, how many ways is there for them to do that? Only one way. Okay? So it gets bigger and bigger and bigger until it gets to about 25, choose 13 or so, like right in the middle of the list. And then it starts to get smaller again. Goes all the way down to 25 choose 24 ends up being the same as what 25 choose 1 would have been. Just an interesting thing you can note. Okay, moving on to number 5. If I'm going to order a random 2-topping pizza, what's the probability I'll get a 2-meat pizza? Think about the things that are possible. All the things possible go on the bottom. Things you want go on the top. I don't want to do this to one of you guys to make you teach because this is a tougher one. Everybody try this on your own. See if you can figure it out. I'll pause it. Okay. I think a lot of people are concerned whether they're doing this one right. And I bet they're forgetting about a way they could check their answer. Here's how I would have done it. I would have said there's 25 total choices and I'm going to choose, this is a 2-topping pizza, so I'm going to choose any 2 of them. Because all the toppings were possible. Okay, and then what do I want? I wanted it to be meat. There were 9 that had meat, and I'm going to choose 2 from that. And do you remember how you can make these things balance? Well, if you include everything you had a choice of on top. My other choices were the 16 other things, and I wanted to choose 0. Then this will balance because this plus this should always equal that, and this plus this should always equal that. You remember that now? Look for that when you're setting up probabilities where there's stuff on the top, stuff on the bottom. They'll balance. It's a really smart way of checking your work. It'll happen again on the card problems. Okay, in card problems, is it C's or P's? Does the order they deal them to you, when you pick up 5 cards, does it really matter what order they came in? No, therefore the order doesn't matter. Yes, there are certain games where it could, but we're going to use C's for these. And if I'm talking about all the possible hands you could get, I got to know how many cards are there in the deck. Well, there's 52. And then this kind of depends on the problem. If they want 5 cards, like this scenario, then there's 52, choose 5. Okay, that's all your possible things. All right. Now, in this one, they're asking about a probability. That tells you there's a top and a bottom. I'd like you to see if you can do this with those C's. Maybe you'll need even more C's than that. Set it up yourself. Everybody on your own. Okay, I'm sensing that most of you guys are done. Let's say Mr. F. Fossey, what do you got for the bottom? 52, choose 5 was all the things that were possible. Good. Okay. All right, and how about for the top? 13, choose 3. 13, choose 2. Excellent. How many of you remembered to make it balance like that? Good. That's most of you. Okay, this and this and this add up to 52. And this and this and this add up to 5. So you can be sure you did it right. Just tell me the grand total, final answer. 0.009? 858 would round to 9. Okay, 009. So there is not even a 1% chance it would round to 1%. About a 1% chance of that. Pretty slim chance. All right, it'll be just like that. You're going to set up this next one, except it's not a 5-card hand. It's a 2-card hand. And it says, in this 2-card hand, what's the probability of getting 1 ace? Person on the left, I want you to be the teacher. Person on the left, explain how you'd set this one up. Don't even have to calculate it, just show them how to set it up. Okay, so they're finished with that. It's 52, choose 2 this time. That's the key difference there. And I have 4 aces in the deck and I want 1. And this is not balancing, so I need the other part. 48, choosing 1. Now it balances.